Hello all, here is a question which is asking if the given transistor circuit is operating in cutoff or saturation or active region. So that's the question that is being asked. So to answer this question, right, first a simple thing, if you are working on this in a competitive exam, the first thing that you can see is this is a PNP transistor, right? This is P, this is N, and this is P. So if you see this, so you can think of this particular base and collector junction like this, right? From the collector to base, you can think of a simple diode, right? That's how it is. In NPN, how do we see? It's just like a diode with a breakdown of zero point 0.7 or whatever, as a diode between the base and the emitter junction. So similarly, you can consider like this. Now, to simply answer this, you see here, this is around 5 volts that is provided. This is around 5 volts that is provided. Simply, straight away, by looking at this, you can say that there is no current between the collector and the base terminal, and here itself, we can directly say the transistor is in cutoff region. Now, that's the simplest way of doing. Now, if you want to analyze further and see, you can also like apply Kirchhoff's law in this loop, and you can understand that the current will be flowing towards inwards to the supply rather than to the base, because for this particular transistor to be on, you need to provide the required base current, right? So the current direction will be in outward direction. So you can just do a simple Kirchhoff's law here. If you assume that this is IC, okay, and this is IB, so IB will be in negative direction. So that itself indicates that the transistor is never on. So this simple criteria can be used to say that this particular transistor is in cutoff region. Now, just for a generic understanding, so if you have a emitter terminal and if you have a collector terminal, okay, if emitter terminal is forward biased, okay, and collector terminal is also forward biased, then in that case we will have this in saturation region. The BJT will be in saturation region. Now, if you have this emitter in reverse bias condition and collector also in reverse bias condition, then this will be in cutoff. That is the one which we are seeing here. So this is in cutoff condition and this also is in cutoff condition. That means you do not have an option to bring this with these conditions, operating conditions. You cannot have this in saturation. Now, if you have a particular emitter junction in the forward bias and collector in reverse bias, then it will be an active region. So that will be a consideration where you say IC is equal to beta IB. So the collector current varies based on the base current and the HFE of the BJT. So that's what happens in the active region. No, that is not the point of consideration now. So simply by looking at this table, okay, if this particular circuit has to be in operating condition, the simplest thing that we can say is here we have to reduce the voltage, right? So for this to be operational, we have to, if we want to make this forward biased, the collector junction to be forward biased, that means this voltage should be less than this voltage, so that this the junction turns on. So if this voltage has to be less than this, that means if this is 5 volts, we have to make this voltage lesser so that this particular transistor turns on. That's the simplest thing that we have to do. Now, this we will try to prove in simulation as well. Let us see what happens. This is the circuit we are seeing in that, right? What we have analyzed. So we have a PNP transistor, and then we have 5 volts DC through 5K resistor to collect the emitter terminal, and then at the base you have 5 volts through 100K. So now, if you try to simulate this, okay, we are going to do a transient analysis for 2 seconds. Let us skip it, okay. And if you run this, and if you try to probe the voltage, okay, let us try to probe the voltage here at the emitter side. Now you can see here it's 5 volts, so which itself indicates that this particular transistor is not turned on. Also you can see here, if we probe the voltage here, so this also is 5 volts. That means at this junction this is 5 volts, this is 5 volts. That means there is no current flow between the emitter and the base, right? Now if you try to probe here, you can see this is 0 volts. That, and then if you try to probe the current here, okay, so that also is a negligible value of 0 amps, right? Now this indicates that this particular transistor uh, with the given operating conditions is in cutoff region, and there is no current flowing across any of these terminals. Now, as we discussed in the theoretical thing, we said if you reduce this voltage here, that means the voltage that is being applied to the base, you are actually trying to turn on this particular junction, right? So, and then in that case, you will see the current flowing. So now, let us make this some 2.5 volts, okay. Let us try to close this, okay, and run this. Now let us try to see the current here first. You can see there is 2.9 microamps current that is flowing, and then you can also see the voltage here, it got dropped, okay. That means it hasn't turned on completely at least, but there is a current flowing, okay. So you can reduce further voltage and try it on your own, but we are just giving and trying to show a condition where if you are reducing the voltage, you can see there is a current flow gradually happening, and if you also probe here, you can see there is a current that is flowing. So this indicates that basically the given circuit, this particular circuit what was given, which is actually a 5 volts, is in cutoff condition, okay. So please post if you have any questions. Please let us know your thoughts on this. Thank you.